Okay, this is section 2B. So this is mostly about critical points, points of inflection, and reading graphs of derivatives. So this is the first one. It's talking about a relative maximum. Basically, you are given this function. You don't know what k is, but you do know that x equals -2. It's going to have some type of max. So you're trying to find what is that k value, essentially. Take the derivative, which is this guy right here. Go ahead and plug in -2 for your x. Cross multiply or just solve for your k. K should equal 4. The next one, y is a function of x such that the derivative is always positive. So if the derivative is always positive, this guy right here, that tells you that you're always going to have your f above the x-axis. I'm sorry. The derivative is always above the x-axis, which means your f is always going to be increasing. This is your second derivative is negative, which is going to tell you that this guy should be concave down. So you're increasing and your concave down. The only thing that this could actually be would end up being B. This is a nice concave down shape. This looks more concave up. This is concave down, but it's decreasing. This is kind of concave down. You have some increasing and decreasing going on. This is always increasing, but you're not really getting that concavity that you're looking for. Point of inflection, so this is going to be the second derivative. First, here's your function, first derivative, second derivative. Solve for your x. So you have a possibility at 0 and you have a possibility at 3. You want to make sure that you do a sign chart, because if you look at 0, it's positive and stays positive, so there isn't actually a change in concavity at x equals 0. They went ahead and put y values in, which is great. You don't really need to solve for them. You're going to trust them. X equals 0, which of the following is true about this function? So you're trying to see is it increasing, decreasing, discontinuous, relative minimum, relative maximum. Now this is the combination of two continuous functions, so it's not going to be a discontinuous function. So you're going to focus more on increasing, decreasing, min or max. What I did is I went ahead and I took the derivative, because even to get increasing or decreasing, you're going to need to know something about the derivative. Here's your derivative. I went ahead and straight evaluated it, and you had it was negative decreasing. It was a negative value, so that meant that it was decreasing. But all you can do with that, the min and the max, you would have needed kind of a sign chart to figure that out. And because we got this ugly derivative, it wasn't one that we could actually solve for x without a calculator. So that's why I also decided to not focus on those and focus on increasing and decreasing. So I evaluated the derivative. It was negative, therefore decreasing. This is one I probably should put in a different section. Not a beautiful one. So f is continuous, so you need to know that. And a relative maximum at -1, 4, and a relative minimum at 3, -2. So I kind of sketched it out here, and I looked at what was going on, and it said point of inflection, so change in concavity, that you would have a horizontal tangent. So your derivative would be equal to 0 at -1. There's no indicator to tell you what was going on to the left of -1. So there's nothing for me over here that say, oh yeah, you're definitely going to have that, because if you look at how I drew it, I just kind of made it a linear function. So there's nothing that's going to tell you that you're necessarily looking at a horizontal tangent, a change in direction. Horizontal asymptote, somewhere in between there, there's no guarantee you're going to have a horizontal asymptote. It's not telling you you have a rational function or anything. Horizontal tangent at x equals 3, so now we're going to do a horizontal tangent over here. Well, you don't know that it goes up. I can make it just continue down and be a nice linear function. So you're really not knowing anything about having horizontal tangents. Point of inflection is the concavity. There's really nothing about concavity that's being implied. It's just giving you 2 points. It doesn't say that it was, zigzagging in between. The thing that we can kind of pick up on is if I look at the idea of basically just connecting the dots like I did. So just connecting these two guys, it intersects the y and it intersects the x, and that's actually based on the intermediate value theorem. So this is, you know that you have a 4 here and you have a -2 here in y values. Intermediate value theorem says that function has the possibility to take on every single y value in between those two things. So the function can't spike up, okay, because we don't have anything above 4, and it can't swoop down below 2. So we just know that it's going to take on all the y values in between 4 and -2 based on the 2 points that we were given. So that's why it's E. You're doing concave up, which is your second derivative. So concave up, second derivative. It's this guy down here. Make sure that you're evaluating all of your points. I mean, you're taking the square root of a number, you get your positives and your negatives. This is an older test, so you're definitely going to, hold on. Yeah, so this is an older test. They weren't using interval notation yet. You should have interval notation on your test, so nothing too big to worry about. The next one, you have a graph of your derivative is given here, and what I did is I resketched it. When it's decreasing, that's going to imply concave down. When it's increasing, that's going to imply concave up. And then when it is above the x-axis, your original function is increasing. When it's below, your original function is decreasing. And you should have horizontal tangents at -1 and 1. That's all the information you should be able to pull from those graphs. So basically, that's going to take away D. That's going to take away E immediately. The next thing you need to focus on is you need horizontal tangents at 1 and -1. That's not happening. You have zeros at -1 and 1 on A. So really you're looking at B and C, and you'll see that they're kind of reflections of each other. So I went ahead and I broke it down from -infinity to 1, 1 to -1 to 0, 0 to 1, and 1 to infinity. And the concavity and whether or not it was increasing or decreasing. Got myself a nice little sketch, and that's why you would go with B. So if it's asking, and you're going to have a question like this on your exam, sketch it out. It took, less than a minute. This is a graph of the function f, which of the following intervals, and what's to know is your first derivative greater than 0. So dy dx greater than 0. That's going to mean increasing on your f. And then your second derivative, less than 0, that's going to be concave down. So I would say when we're looking, this would be increasing, increasing, decreasing. So we're immediately going to take away this part. And so we went increase and concave down. Well, this is the part where it starts to shift that concave down. I would say in this part that looks more concave up. So I was going to just focus on that. That looks more concave up to me. And this looks more concave down. So really just from B to C, which is B. X equals 3 is where we're concerned with this function. That's where you have some type of discontinuity. There are two things that you're looking for in this. When you're looking at your different choices, it's talking about being continuous and differentiable. For it to be continuous, you basically are looking for that hole to be patched. So remember, this goes back to the first set of multiple choice questions that we did, but for it to be continuous, you need the limit to exist, you need the function to exist at x equals 3, and you need your limit to match what your function exists. So I did a little sketch, and that was confirming that it is continuous. And then the second thing I did is I took the derivative at both places and saw that it was the same. So for this one, this guy is in fact going to be continuous and differentiable. Okay, it is not undefined. There's nothing in there that's telling you that you have a vertical asymptote. Continuous, not differentiable, differentiable, not continuous, and then neither. It's kind of giving you every single scenario. You know that it's continuous, so it's going to take away those two. So you're looking at, is it also differentiable? And it is. Absolute maximum, and they give you that closed interval. So you want to take the derivative, and that's where I got 0 and 2. The next thing you need to do is you need to evaluate the endpoints. So just a little plug and chug math, double check your math. Don't make a silly math mistake. This is non-calculator active. For what value of x does the function have a relative maximum? You can kind of go at your own pace here. What I decided to do, I didn't feel like doing the product rule for whatever reason. So I went ahead and just multiplied everything out and took the derivative either way. These are the two places that you should be checking. And you're looking for a maximum. A maximum would be from increasing to decreasing. So this would have been increasing to decreasing. So that would have happened at 7/3, which is D. Point of inflection, so you have to do 2 derivatives. There's your first derivative, there's your second derivative. I cleaned it up. I factored out 6 over x to the 4th. It's definitely a different factoring we're not really used to seeing. For it to equal 0, that does not exist. So really I'm just focusing on the inside stuff. Set the inside stuff equal to 0, kick the other stuff to the other side. X is equal to 2, so that's what I'm looking for on x is equal to 2. And in this case, that's the only place that you had it. Oh, sorry, looks like it didn't come through, but there's a negative hanging out on that side. How many critical points? So this one I did do the product rule. So this is the product. So this is the original. This is my u. This is my v. U prime, v prime. What I noticed is you have kind of the repetition with all of these little binomials. So I factored out x plus 2 to the 4th, x minus 3 cubed. It left me with 4, x plus 2, and then 5, x minus 3. Distributed out the 5 and the 4, combined like terms, and I got it down into 9x minus 7. X equals negative 2, x equals 3, x equals 7/9. So this one's going to have 3 critical points. Probably should have evaluated each of them as well, but I was being lazy. Next one, you want to know increasing and decreasing. So increasing and decreasing would be from your first derivative. So I got x equals plus or minus 2 as my 2 places. I evaluated, and it was a quick evaluation because you're always squaring in that first derivative, which meant it was always going to be positive, which meant that it was increasing for all x. This is a graph of f shown above. What you're looking for is the graph of the absolute value of x. So this is, I basically am creating a mirror image based on this side. So I want my right side to match my left side because I'm not going to be evaluating f of negative 1. F of negative 1 is going to look like this, which is the same as f of 1. So this is going to make it symmetric to the x-axis, which means I basically need to take this guy and flip him to the other side. So it shouldn't be anything too crazy. So this is a duplicate image of that guy. So I'm going to take, those are basically my x values, and in order to keep the absolute value, we're just going to flip it to the other side. Nope. So it's going to look more like that, which would lead you to answer C. Minimum value of this guy. So to find the minimum, you need to actually take the first derivative. So product rule, your first derivative ends up being 1 plus natural log of x. Solve for your x. Now that's the x value where you have that minimum value. This is asking what is the minimum value. So it wants you to actually evaluate your original function for that x value that you just solved for. And that's why if you're got here and you're like, well, I don't see my answer, it wanted the actual y value, that minimum value. So just one step further on that. This one was just a nice little word. Is it decreasing? So take your first derivative, factor that guy out. The only places this is going to be 0 is when x is equal to 0. So e to the x, remember, is the exponential function. And for that guy, he looks like this. So he never actually equals 0. So we kind of ignore that. So x equals 0 and then x equals negative 2. Those are your 2 places. Do your sign chart, and the only place it's decreasing is between negative 2 and 0. Where is this function concave down? So that's second derivative. You should get x equals 2 and 2/3 as your 2 places as point of inflection. Do your sign chart, and you'll see that it's concave down between 2/3 and 2, which I believe is answer E. Yep. This is the graph of the derivative of f as shown above, which is your original. So exactly what I did in the last one. So you have your 2 places, 2 and negative 2, so you're going to have horizontal tangents there. Decreasing, increasing, increasing, decreasing, concave up because it's increasing, concave down because it's decreasing. Kind of get your sketch and go from there. The only one that he matches would be good old-fashioned E right here. So you're looking for just kind of the same pattern and shape.